Hello, my name is Aaron Fields. This is Injection Soup for INFA 729, Advanced Web Application Hacking, taught by Dr. Josh Pauli. I'll be talking about OS injection, which is over pages 358 through 368 in the Web Application Hackers Handbook 2nd edition, as well as XML injection, which is pages 383 through 390. So what is OS injection? Basically, think about cmd.exe. Anything you can run in there, you can run when we're injecting to the OS. Basically, OS injection allows us to send commands directly to the system that we are attacking. So, dir to list contents of a directory, or ls, for example. Usually, these vulnerabilities that allow us to inject to the OS are found in web interfaces to administrative stuff. So things like enterprise servers, web front ends for printers, routers, etc. And this is pretty bad because whatever run level the web application is running at, for example on a server, is what your command is going to be executed as. So whatever privileges the web app has, same privileges that your command has. More often than not, this is usually enough privilege to wreak some serious havoc on the victim machine. So I put together a little demo in ASP.NET just because that's what I'm familiar with. So let me get that fired up here real quick. This is loosely based on sample code in the book from page 360. So we have a little web app here, one text box and a button. We'll debug it. Essentially what this application allows us to do, if we click the button, is list the contents of the directory that it's currently in. It is set to run in my user directory, so like c/users/spirotot is my username. We can actually type something in this box and it'll list the contents of that directory. So let's do documents. Right, shows me what's in my documents. Pretty simple. Let's take a look at the source code real quick. Basically, on the button click event, it takes whatever the user has entered into the text box, appends it to a string, starts a process in the background using cmd.exe, appending the user's input to the dir command to list the output of that command. Now this is interesting because it does allow us to string more than one command into the system using meta characters such as ampersands. So here we get the output of ipconfig. We can also do cool stuff like start calc.exe. Kinda cool, pretty fun. Now, the interesting thing to note is that I'm actually using code that the book recommends. You can check that out on page 368 in the Web Application Hackers Handbook. We're using process.start. So the issue here lies not with process.start, rather it lies with the fact that we're using cmd.exe. When we pass the user's input to cmd.exe, cmd.exe actually interprets those meta characters, allowing us to run things like ipconfig or calc.exe. So if we try running something like Notepad, using a similar setup, you'll note that it actually won't work. Notepad pops up, but it's looking for ampersand ipconfig.txt. We don't want to create a new file. Close Notepad. And that's all we get for output. So process.start does work in this case. However, when you use cmd.exe, we're still vulnerable to command injection. So I did come up with a solution to this problem using different code, using .NET functions instead, getting the contents of a file directory and dropping it into a grid view. So you can see this in action. A little bit neater than the other one also. Lists my documents, nice and neat. And if we try something like calc.exe, we get an exception. That didn't work. However, this is vulnerable to some serious path traversal issues. So hopefully Michael Ham can help us take care of that. So that's about it for the demo. Static versus dynamic. There are essentially two types of OS injection. We just saw static in action. Static injections always do the same thing. It's taking advantage of compiled code that's already on the server, and it always does the same thing unless you can append onto it with something like meta characters, run ipconfig. Dynamic is a little different. Dynamic web applications will actually compile code potentially supplied by the user at runtime and then execute that code. So it'll run whatever you can throw at it. If you can get something like a response.write into an ASP.NET web application, it'll spit back a bunch of ones at you. For example, here, if you can get a PHP info function to run on a PHP server, you get a ton of goodies from that server. Now, the book talks briefly about scripts, and from what I understand, this is basically the idea of getting malicious code onto a server and then running it in your browser. So for example, in the book, the authors actually found a server that was using the nslookup command and appending user input onto that command. They were able to add malicious code onto that command and pipe it to a file and then browse that file and run the code. So I mean, you can imagine how easy it would be to upload something like a web shell and have a command prompt on that machine. So how can we prevent OS injection? Well, there's lots of things we can do. For example, we can use things like process.start because it doesn't interpret meta characters. However, we do have to be careful because as we saw earlier, things like cmd.exe do interpret these meta characters, allowing the user to still inject arbitrary commands. We also have to be careful because even things besides cmd.exe can bring up vulnerabilities. For example, wget could allow the user to download malicious scripts to the server, navigate to those scripts using their browser, and run the code. You should also take advantage of your environment. For example, like I did with the get files functions. You should also use whitelists so that the user can only supply input that you know is good. However, if your application needs to be more dynamic than that, make sure you scrub the input. Allow only alphanumerics, excluding whitespace, etc. If there's anything else you can strip out too, go for it. So, on to XML injection. What is it? XML stands for Extensible Markup Language. This is a technology used to submit data from the client to the server. It's generally found in applications that utilize AJAX. It's even found in things like browser extensions and lots of other random stuff. Now keep in mind that it's an interpreted language. So if you think of something like HTML, that's kind of what XML is like. Here's an example of what a client's post looks like. You'll notice a search and search term tags help define what data is what. And the server's response. No results were found for that expression. Cool. We can inject into XML by using things called entity references. Somebody came up with the term XML External Entity Injection, XXE for short. Now, entity references are basically a method for referencing data inside of the XML document itself or something outside. So for example, &LT represents a less than sign, &GT represents a greater than sign. Now keep in mind what I said a minute ago. You can use external references. XML will actually let us define our own custom entities. At the beginning of an XML document, you can use the doc type element to define your own custom entity. So for example here, you can create an entity called testref with the value testref value. When a parser sees this, it's going to replace any occurrence of test_ref with its string value, test_ref value. Now let's think about external references for a moment. They're fetched dynamically. They can be anything on the local file system. They can even be things on the World Wide Web. The parser fetches the content of whatever is being referenced, and the contents are used as a value for that entity. So take a look at this. We're going to set up an entity. It's called XXE. System means we're referencing an external source, and file simply means that the URL we're referencing can use a file protocol. Note the search term, &XXE, semicolon. That means that when the server or the parser sees this, it's going to replace whatever XXE is referencing with the value of XXE. Because this is an external reference, the value of XXE is evaluated dynamically. This means that the server is going to go grab the contents of win.ini and display them back to the user. It's going to look something kind of like this. So this brings us to something called SOAP. It stands for Simple Object Access Protocol, and it uses XML to encapsulate data. It's used mostly by web services, most of the time by large-scale enterprise apps. It's also used for things like web front ends to systems. Basically, it provides a lot of modularity and interoperability between different operating systems and applications. Now, it is an interpreted language, so that brings with it lots of fun stuff. So let's take a look at an example real quick. Let's say you go to your bank and you decide you want to transfer some money from account 1828100 to some other account. You want to transfer $1,400, right? So these are the HTTP parameters that get passed to the server. In the background, this gets translated into a SOAP message that gets sent between two back-end machines. Notice how the values correspond to the tags in the SOAP message, and also notice that there's a clear funds parameter that's added and it's set to false, probably because there weren't enough funds in the account for this transaction to happen. So let's say that we pass this in our HTTP request to the server. There's a /amount tag, then cleared funds, true, /cleared funds, and then an amount tag. That gives us the SOAP message below. Now, assuming that the server processes tags in whatever order they come in, first come, first served, we'll have overridden the original cleared funds tag, which said false. We've overridden it with true, which means that this transaction would go through despite the fact that the account does not even have sufficient funds for the transaction to happen. The prevention of SOAP injection is really pretty straightforward. The book suggests basically two things. Boundary validation filters, which it talks about on pages 25 and 28 in chapter 2, and HTML encoding your meta characters, such as a less than symbol, greater than symbol, the /sign, etc. So yeah, really pretty straightforward. Validating user input and stripping it or encoding meta characters. So that's my presentation on OS injection, XML injection, and by proxy SOAP injection. So I hope you guys enjoyed it.